Hey everyone, thank you very much. So today we are going to solve the problem. So the problem is like this. So imagine you have a bar. It's not a bar, a beam. It's pin joint, and one of them is roll. So you have by, and then you have ay, and then you have ax. Okay, and then there's a distributed load where the load is 100 newtons. Yeah, and then there's another forces, which is 50 newtons. The question is how to determine the equilibrium of this system, calculating the reaction force AX, AY, and BY. This is a dummy question for those of you who don't know how to apply equilibrium equations. So first, what you need to do is you have three equations. The first is the sigma moment equals 0, sigma fx equals 0, and then sigma fy equals 0. Okay, and this is x, this is y. Okay, so moment, it will be, if it's like this, it's called clockwise, and it is negative. Yeah, and if it's like this, it's counterclockwise, CCV and CC. No, it's CV clockwise, not CV, CW, CCW and CW. So what you need to do to solve this is just using this equation, sigma fx equals 0, and then you realize that there is only AX working on it, so it means AX equal 0. Yeah, because only AX, and it's the arrow pointing towards the right side, which is positive, so AX positive and equals 0. Okay, and then if you apply the second equation, sigma fy equals 0, check, is there any forces working on the y direction? Of course, AY, which is pointing upward, which is positive, and then BY also positive, and then minus 100, and then minus 50 equals 0. So AY plus BY is equals 150 Newton. Okay, but you still cannot determine what is AY and what is BY. So what you need to do is to take this third equation, sigma moment equals 0. You see here, if you want to find BY, take the moment at A, because AX and AY will create 0 moment. So you can isolate the system and get BY. Yeah, sigma moment at A equals 0. Then you will get BY. BY with respect to A will create, what kind of moment is this? It's a counterclockwise moment, which is positive, and times the distance from here to here. Let's say this is 10. Yeah, so 10 meter, for example. I didn't mention from the beginning, but it's okay. And this is, let's say, 4 meter. Yeah, so it's not exactly in the middle, BY. And then that 50 minus 50 times 10, and then minus 100 times 6, yeah, equals 0. And then you can delete this 10, yeah. So your BY will be, how much is this? 50 plus 60, which is 110 Newton. That is the value of the BY. And it makes sense. BY is bigger because there are two loads working closely near to the BY, yeah, instead of AY. There's 100, which is only 4 meter compared to the BY, and it's 6 meter to the AY. And then also there is 50 newtons load, which exactly working on the same axis as BY. And then how to get the AX and AY? Once you get BY, you know that AY plus BY equals 150, yeah, and AY is 150 minus BY, which is 150 minus 110, which is 40 newtons. Yeah, so now you get everything. You get the AY, okay, you get the BY, and then you get the AX, and everything is now solved. Okay, and that's how you solve equilibrium equations. And I hope this clear enough. Yeah, so this is how you apply equilibrium equation for those of you who just start learning how to implement equilibrium equation to your structures. See you again in the next video. Bye.